Okay. All right, as I look out at all the beautiful people here, you guys are young, you're in shape, you look pretty healthy to me. How many of you guys do things during your day to try to give yourself the best health that you can? And what do you do? Tell me some things that you do to stay healthy.
2-hour walks every day.
2-hour walks every day. Get some exercise, right? What else? You go to the gym, okay? Hit the iron. Some people run, right? So exercise, we know working out. Build some muscle mass. Get your cardiovascular system going. That's one thing we do to our health, to help our health. What else do we do?
Eat healthy.
Eat healthy. We're all about diet, right? You know, when I was a kid, it's like cut out the fat. Then in the 90s, like cut out the protein. Now it's like cut out the carbs. So we love to demonize food here in the U.S. I don't know what's up with that, but you know, we try to eat healthy, eat the right amount. Don't eat too much. Don't eat too little, right? So we exercise, we eat well. What else? What do you have in front of you? Right here. Carry around your water bottle, right? You're supposed to drink, what, 48 glasses of water a day? I don't know, it changes all the time, right? Stay hydrated. What else? What else do you do to try to stay healthy?
Clean yourself.
Stay clean. What do you not do to stay healthy? You just told me of things you do, but there's things that we probably shouldn't do, right? What shouldn't you do if you want to stay nice and healthy? Don't do drugs. Don't smoke, right? One thing I didn't hear any of you guys say is live over the right type of rock. You know? How many of you like get up in the morning and is like, geez, I gotta go stand over the right rock today? Nobody does that. But you'll think of 20 other ways to keep yourself healthy, right? Well, as it turns out, I'm guessing everybody in the last 5 seconds took a breath. You inhaled, you exhaled. How many times you do that a day? Thousands, right? You are breathing in stuff right now. That is not good for you. One of the things you're breathing in is something we talked about a little earlier called radon gas. Radon gas is a radioactive gas. It is more common in some places than others. It happens to be really common around here. It is the second leading cause of lung cancer in the United States, behind smoking. And it's close. Here you can be doing all the right stuff. You can be drinking all the good water in the world. You can be having the perfect diet. You can work out 4 hours a day. You can do all the stuff for your health, and you can die at a good young age just because of the rocks you lived over. And it's something I want to give you an appreciation for. This is one of those things. How many of you want to own a home someday? Most people still want to own homes. In this area, if you put a home up for sale, you have to get a radon test with it. It's that serious. And when you buy a home, you should look seriously at those radon readings. When I moved here to Colorado, I found a nice home over in Fort Collins. I really wanted to buy it. My daughter was in love with this place. We got the radon levels back, and it was 5 times the healthy limit. And I said, nope, not living there. And I'll show you why here in a little while. It's actually really serious. So I want to give you an appreciation for things that can affect you directly that you might not think of. So let's sort of set this up first. So I'll give you a little science, and then we'll talk about the ugly stuff. So each and every one of you is different, but you're really similar in some ways. And one way that you are very similar is in the makeup of your body chemically. We are all actually, as it turns out, pretty simple when it comes to chemistry. Humans are made up almost entirely of just 6 elements. Anybody want to take a guess at what the most common element in the Earth's body is? Carbon is a good one because it's in all of our cells, right? What else might you expect to find in the body in high amounts? Water, H2O, right? Because we know 60% of our body is water, right? So we know there's lots of hydrogen, lots of oxygen, lots of carbon. Okay, got another one? Iron. As it turns out, iron is not in this list. But you need iron, don't you? Do you need iron in your diet? Let me put this list up first. There's the 6 most common right there. Oxygen is actually the most common element in your body. It combines with carbon and hydrogen to make up a lot of your cell materials. Basically, these first 3, oxygen, carbon, hydrogen, makes up the soft stuff in you, all the cellular material, the muscles, the fat. Water. These last 3, nitrogen, calcium, phosphorus, most of that is in your skeletal system. The bones, the hard stuff. So the first 3 is the soft stuff, second 3 is the hard stuff. Human skeleton doesn't weigh much. It's only like 20 pounds. So most of you is the soft stuff. But that accounts for 99% of you. There's still 1% unaccounted for. And as it turns out, that 1% is ridiculously important for you. And in fact, without that 1%, you're as dead as that table you're writing on. You are dead, 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 dead. You mentioned iron. What does iron do in our body? You guys know where you find iron? Yeah. What's that? It's in the red blood cells. Yeah, it helps you carry oxygen. Without iron, do you know what the human condition is called if you don't have enough iron? And you can't carry enough oxygen to your cells? It's anemic. You guys heard of anemia? Anemia is one of the most common conditions from low iron because it affects your blood's oxygen carrying capacity. So we know there are things that are on this list that aren't on this list that are really important to your health, right? That extra 1% not accounted for with those first 6 are something that we call trace elements. You have lots of trace elements in your body. Lots of things that are measured in tiny amounts. Iron is one of them. You have some gold in you. You all have little bits of gold in you. Silver, lead, platinum, copper, potassium, iron, magnesium, dozens of these trace elements. And the neat thing about these trace elements is that they are absolutely essential for human function. They're called trace elements because we measure them in trace amounts. Typically, these are measured in ppm, ppb, which is part per million, part per billion. But even though something might be measured in parts per billion, if you don't have any, you could be dead as a doorknob. Many trace elements are absolutely essential for human health. You have to have them or you get sick and you die. And then there's some other trace elements that aren't essential, like radon. You don't actually need this in your body. You don't want this in your body. But if you get it in your body, you can get really sick. Yeah?
Does every person have like the same amount of the trace elements, like ppb or ppb?
Great question. Does every person? So, do you have the same amount of iron in you as me? The answer is no. Should we have exactly the same amount of iron? Probably no, but we should probably be close. You have a different genetic makeup than I do. You probably expend calories different than I do. You're younger than me, unfortunately. So all those things play into how much of these trace elements we might need. So there's how much you need and then there's how much you get. And depending on some things we'll talk about in a minute, you might get a lot more iron in you than I do. And that goes the same way with lots of these other trace elements as well. Do you have a question? Okay. I'll give you some examples. So I don't care if you write this down, but what I'm going to have here is a little table. Got the trace element here on the left. Average body concentration, how much sort of an average person has. It varies a little, age, genetics, diet, whatever. What it does in your body, what's its function, if any, and then finally, what happens if you don't get enough? What's the deficiency disease, or the disease that you get for having too little or being deficient in these trace elements? So here we go. Here's iron. 60 parts per million. That's it. That's all that's in your body, 60 parts per million. Out of every million atoms in your body, only 60 are iron. Its role in the human body is in the red blood cells, the hemoglobin. And what it does is it allows your blood to carry oxygen to the cells and muscles. Without that, if oxygen is not getting to your cells, that is a condition called anemia. And it sucks, and it's not fun. Iodine. We're going to talk about iodine in detail here a little bit. 0.2 parts per million, or 200 parts per billion. So 1 atom out of every 5 million in your body is iodine. Believe me, you want that 1 atom, because if you don't get that, it messes with your thyroid function, and you end up with a disease called goiter. Has anybody but Jesse ever seen a person with goiter? If you have, you would not forget it. I'll show you what it looks like here in a minute. This is not something you want, okay? Just the rest of the list here. Copper is an element that ends up in lots of enzymes in our body. Enzymes are things that help chemical reactions occur. The result of not having enough copper is that you can have high cholesterol. Fluorine, we know that some waters and toothpaste have fluoride in them. Fluorine is the trace element. So we know it is a factor in bone growth, and if you don't get enough, it can exacerbate tooth decay. Chromium, cobalt, zinc. One is involved in insulin. The other two have a lot to do with metabolism, loss of energy, growth. Bottom line, if you don't get these, even though they are here in really tiny amounts, you can be really sick, or you can die. Question?
You said that we have gold and silver in our body.
Yeah.
Are they essential?
She asked, she had heard gold and silver is in the body. It is. Are they essential? We're going to talk about that right now, and no, they're not. Some trace elements are essential. You have to have them or this happens to you. Some are not essential. And so gold, silver, lead is a big one, okay? Lead is not an essential trace element. You all have lead in you. Every last one of you has lead in you. Now, your bodies can handle small amounts of these unnecessary trace elements. If you get an atom of lead or an atom of even uranium or even radon, your body's going to be able to handle a little bit of this stuff. But if you get too much, lead, it can lead to mental problems. It can lead to stunted growth. It can kill kids. That's why we took lead out of paint. That's why we took lead out of gasoline, because it was accumulating in people's body at concentrations that were making them sick. So some things are not good for you, but you can handle them in tiny amounts. And what I'm going to show you next is exactly how that works. So that's a great question. So, yeah, question?
How do you get copper in you?
How do you get copper in you? The same way you get iron in you, which is something we're going to talk about next. I can kind of spill the beans on this. So, okay, so Let's start with this to get to your question. Your health is absolutely dependent on getting these trace elements, okay? You have to get enough of the trace element so that you don't have a deficiency disease. But what happens if you just ate handfuls of iron supplements all day long? It's like, I am going to have a bowl of iron supplements for breakfast today, and then I'm going to have a bowl of it for lunch, and I'm just going to eat iron all day long because I heard iron was good for me. Do you think that's going to be good for you? No, it becomes toxic at high levels. All these things, if you don't get enough, you can get really sick. The flip side of it, if you get too much, you're also going to get sick. So how do you get copper in your body? Same way you get iron in your body. Same way you get water in your body. Water you drink, food you eat, air you breathe. Does food have iron in it? Does food have copper in it? It actually does. Some food has gold in it. Where does your food get its trace elements? So if I eat, let's say I eat plants, I get certain trace elements. If I eat different plants, I might get some other trace elements. If I eat those same plants, but they were grown 50 miles away, I might get slightly different trace elements. Because think of it as a plant first. Where's the plant getting its nutrients from? Where does the plant need sunlight, water, and nutrients? Sunlight from the sun. Where does it get water and nutrients? From the ground, right? From the rocks and soil that are in the ground. So if you grow corn here over one type of soil, it might have different trace elements than corn grown in Iowa over a different rock type that has a different chemistry. And if those rocks have copper in it, the soil might have copper in it. The plants growing on the soil might have a little copper in it. The cow eating the plant on the soil over the rocks might have a little copper in it. And then you come and eat the cow, and then you get trace elements that have come all the way up through the system. So your health is dependent on you getting the right amount of trace elements from the environment. What I have here is kind of an explanation of how this works in your body. So this is something called a dose-response curve. So the y-axis going from left to right is the dose. Over here on the left means you're not getting any in your diet. This is no dose. You're not getting any copper in your diet. You're not getting any sodium in your diet. As you go to the right, that amount increases. So by the time you're at the far right, you're getting really high levels into your body. On the y-axis here, this is the response to the dose. Will you be sick? Will it have no effect on you? Or will you get a health benefit from that dose? Okay? So I'm going to give you 3 different scenarios here on how it works. This first one we talked about a little already, is where there's no known need for it in your body. Your body doesn't need this stuff. There's nothing your body's going to do with it, okay? But in high doses, it's going to be toxic to you. This is stuff like lead, mercury, radon, okay? High doses, you're going to get really sick and die. At low doses, is it going to help your health? To eat one, I found a paint chip, leaded paint. I ate one paint chip with leaded paint. Is that going to kill you? It's going to make you sick? Not one. It's not going to have any effect, right? Is it going to help you to eat that paint chip? You're going to feel all spry and like, I'm going to go run 10 miles because I ate a leaded paint chip? No. So at no dose, it's going to have no effect. Doesn't help you, doesn't hurt you. Your body can handle a little bit of it, right? So you eat a couple paint chips. You're still going to be okay. But what happens if you ate a bowl of paint chips for breakfast every day, bowl of leaded paint chips? What's going to happen to that amount in your body? What's going to happen to the dose? It's going to increase, right? It's never going to help you, right? But what's going to happen at some point? At some point it gets to be too much, right? Then what happens to your health? It takes a dive, right? That point at which it becomes unhealthy to you is what we call toxic. It's becoming toxic, okay? Up until that point, there's no effect. So it would look something like that. Eat a paint chip, you're fine. Eat 10 paint chips, you're fine. Eat 50 paint chips, you're still okay. At some point, though, you're going to have too much. And this exact point is going to vary from person to person. Be a little different than you, than me, because of our genetics, our age, our lifestyle. But at some point, with every person, you're going to get a point where it's going to become toxic. What if you eat another bowl of paint chips after it becomes toxic? You're going to get sicker, right? You're dumb, though. Really like those paint chips. Keep eating them for breakfast. Eventually, it's going to get to the point where your body can't handle it. Shut down. You're going to die. So that's how an element that your body doesn't need works. So that could be gold, silver, lead, mercury, radon. Your body doesn't need it. It can handle it in small doses. If you get too much, it gets toxic. If you're still dumb and keep eating it, you end up dying. This next one is kind of interesting. This is essential. You have to have it. And we don't know of any dose that's going to kill you or even make you unhealthy. I think the best example of this isn't actually a trace element, it's a trace molecule called citric acid or vitamin C. You guys need some vitamin C, right? Do you guys know the disease you get if you don't get your vitamin C? Scurvy. Scurvy sucks. You don't want scurvy. Luckily with vitamin C, if you take too much of it, your body just gets rid of it. Anybody in here take vitamin C? Any vitamin takers? You know what happens if you take too much vitamin C? Nothing to your health, but if you go to the bathroom, you'll have day glow urine. It'll be like bright orange urine. And what that is that's your body just getting rid of the excess. You just pee it out. It doesn't have any harmful effect on you. It's just really interesting urine. It's water soluble. You have so much water in you that water can just pick up the excess and just pee it out. So let's look at how this will work. So if you're not getting any and it's essential, but you don't take any, is your health going to be good or bad? It's going to be bad, right? You need some, or you're probably going to, if you don't have any, you're going to have scurvy, all right? If you don't want to have scurvy, what do you want to do? Take some vitamin C, right? Eat some orange. Increase the dosage. So as you increase the dosage from 0, you will increase the benefit to your health. But at some point, more is not better. Your body can only handle so much. But in this case, more is not worse either. So if your health isn't going to get any better, it's not going to get any worse, what's going to happen is you increase the dose from here. You're just going to have a general level of good health, and you're going to pee bright orange every day. So you'll have a deficiency disease, scurvy, early. You're going to hit some maximum benefit, and then you're just going to pee out the rest. So take your vitamin C. Get the chewable ones. It's like candy. As it turns out, most trace elements act this final way. And so does water, which isn't a trace element at all, but water is kind of a useful way to think about this. So it's required. If you don't get any, you're going to be sick. But it's toxic in high doses. So if you take too much, you're going to get sick. So how's this going to work at no dose? You're not getting any. Going to be healthy? No, it'll be like this one. You're going to start out really sick. Think of water. What if you don't have any water in your body? What's that condition called? I didn't drink enough water today. I feel really dehydrated, right? You're going to be severely dehydrated, and if you're dehydrated enough, you're dead. If you don't want to be dehydrated, what do? Drink your damn water, right? The more water, the better, up to a point. But at some point, drinking more water isn't better. It's not going to harm you. Maybe that's a few glasses of water a day, maybe it's 10. It depends on you, the environment you're living in, how much activity you're getting, etc. But as it turns out, with water and with most other trace elements, if you take too much, you can get really sick. With water, it's a condition known as hyponatremia. You can actually drink so much water that you can die. What it does is it upsets the balance of electrolytes, salts in your body, and your heart stops. They discovered this about 30, 40 years ago when these ultra-endurance events started becoming popular, like 50-mile runs and Ironman events. And what they were finding is some of the athletes were only drinking water during the whole event and not replacing their salts. So they were sweating out the salts and they were only replacing it with water. And then they would feel more and more thirsty and drink more and more water and get sicker and sicker. And some athletes actually died from drinking too much water. But that can happen with iron. You can get iron toxicity, magnesium toxicity, and so on. So if you increase the dose too much, you will actually hit a level of toxicity and die.